Okay, so the first thing we did was we thought of two numbers, and we're looking for two numbers that added up to 20, right? Boy, nobody's paid attention to any instructions so far today. And this was supposed to be done in red, correct? Yep. So these are all the numbers y'all come up with. Excellent. I'm going to draw this line in maroon. Can't be doing any canyon colors here. Okay. And that was our two numbers that went to 20. Okay, now we go again. This time I need for you to think of two numbers that have a difference of, we're going to do these in blue, a difference of 7. Larger number minus the smaller number. The larger number will be first. Okay, let's go plot those. Okay, so when we look at this, you'll notice that I've got a point up here. Does that one really make sense? That actually gives us, I believe, a negative 7. Okay, so if I draw what y'all got, we got kind of this thing going on. Do you see where the solution is? Is it pretty? No, not at all. So we'll do a little work to figure that out. Are there any dots that have a sum of 20 and a difference of 7? No, because they're not pretty. Nobody ended up plotting that. But there is an intersection, just nobody plotted that point because it's not pretty. So this is us solving it graphically, but in this particular case, we see it, but we would be estimating because we don't really know what it is. So now we want to write an equation to model two numbers that have a sum of 20. So how do we do that? Two numbers that have a sum of 20. It sounds like they equal 20. What are they? Totally. Then we want to write an equation to model two numbers that have a difference of 7. So once again, my difference is going to be, whoops, not 20. 7. So how do I write this one? Perfect. In each case, they want us to solve for y. So when you see x plus y equals 20, how do I get y isolated? Subtracting what? X. So I'm going to do y equals 20 minus x. Could I also do negative x plus 20? Definitely. Okay, what about the other one? Or we could what? Is there another way we could do it? I was kind of thinking, what if we added the y and subtracted the 7? So we could subtract the 7 and add the y. You'd get to the exact same place if you subtracted the x and you just got to multiply by a negative 1. So it's just a different way to do it. Okay, what I really want you to notice is look what both of these equations equal. They both equal the same thing, don't they? Though that y we are looking for is this y value right here. And they both equal the exact same thing. Y is the same, right? Y equals y. So now they want us to take those two equations and we're going to put them together to just be one equation. Well, if this equals y and that equals y, can't I just make this equal to that? So I can say x plus y equals, oh, no, I don't know what I'm doing. I can say 20 minus x equals x minus 7. Because those both equal y. Now I just have to solve it. And when you get to this point, you should be down to one variable. When we solve it, we're going to get our x value. So what would you do to solve this? Add 7. So I get 27. Couldn't I also add the x? And I get 2x. And so then x equals what? 27 halves. Which makes sense because our answer is ugly, right? Keep in mind, this is only the x. Our solutions are always points. because we have two equations. So now how do I get a point now that I have the x? So I could plug it into this one or this one. Which would you prefer? Or of course I could plug it into one of the originals as well. Which do you want to plug it into? It does not matter to me. The second one, so we're going to say x minus 7 equals y. And my x value, of course, is the 27 halves. Oh, it's a fraction. That's horrible, isn't it? Okay, I'm going to show a real easy way to get a common denominator. Since we are adding or subtracting fractions, you have to have a common denominator, correct? Okay, I need what number on the bottom of that 7? 2. I need to get a 2 there. I can always, always, always multiply by 1. Do you agree? 1 times Izzy is still Izzy, right? Okay, the one I'm going to multiply by, though, is 2 over 2. Is 2 divided by 2 1? Okay, so that's going to give me, I got 27 halves minus 7 times 2 is 14 over 2. 14 over 2, isn't that the exact same thing as 7? That's how you get a common denominator. 27 minus 14? 13 halves. And that's our solution. Does the y value look like it's 6.5 on our graph? Does the x value look like it's 13.5? There you go. We did great. We okay with that? Okay, so let's try some more. A system of equations is a set of blank or blank equations. What do we think? What goes in our blanks? Oh, it's a good thought. Like it? That's not it. A system of equations is a set of blank or blank equations. Huh? Well, then what would the or be? What do you have to have a system of equations? If I have one line, do I have a system? So how many do you need? 2 or more. A solution to a system of equations is a intersection that intersection is at a, so we're going to write it as a point. We could also call it a coordinate, right? Okay, so looking at our first scenario, given the system x equals 3 and y equals x plus 3, what is the solution? And they're giving you A, B, C, or D. Now, if you were taking this on a calculator test, you could just graph both of these, right? Find the intersection, boom, you got your answer. Now, we're not, so we're going to do a process of elimination, and then we're going to actually find the answer. The first one says x equals 3. So when you look at A, B, C, or D, is there anything you can eliminate? No, because in every single one, x equals 3. So that didn't help us out at all. But then algebraically, we've got our y equals x plus 3. So now what would I plug in for x to be able to solve this? Because x equals 3, so y equals, okay, so now do we have an answer? And it would be, okay. Now we're going to do it graphically. X equals 3, is that a Hoy or a Vux? Vux. Does anybody not know what Hoy or Vux means? Okay, so here we go. I'm going to do it just to cover it. So I got Hoy and I got Vux, right? Hoy means it's going to be horizontal. It has a 0 slope. And it's y equals, and it's whatever that number is. It's going to be a horizontal line. So if you have y equals, that means you got a Hoy, which means it's a horizontal line. Vux means it's going to be vertical. What kind of slope does it have? It's undefined. Can't read that. And then it's x equals whatever the number is. So this is going to be a vertical line. So do we have a hoy or a vux? So we're going to draw a vertical line where x equals 3. Then we have to graph this one. Is this in slope intercept, HK, or standard form, which is actually general form? Standard form looks like this: AX plus BY equals C. Slope intercept or HK? Yeah, because this is MX plus B, right? What does B represent? So I'm going to go to Y and I'm going to plot a 3. And then from that point, I'm going to use the slope to get more points. What is the slope? It's not 0. It's 1. 0 times x would be 0. It's 1. So I got up 1 over 1, up 1 over 1, up 1 over 1. And there's our answer right there. Is our answer on our graph the same as what we chose in our multiple choice? So do you see how these two should go together?
Hey, we did pretty good. We're going to keep Raptor open just so we can account for a few more people.
Okay, so now we got to do the same thing. Let's look at, we're going to graph these first, and then we're going to follow up by doing, by solving them. When you look at this first one right here, is this in slope intercept, HK, or standard form, which is what you're used to it being called, which is AX plus BY equals C. But as we're approaching college, I want you to understand this is actually called general form, okay? HK, okay, so if it's an HK, that means it's giving you a point. Can you write down on your paper what that point is? Did you get it? Okay, here we go. Drum roll, Pete, please. Did you get -1, 0? Sweet, so let's graph it. Then we have a slope. From that point, what are we going to do with our slope? Up 1 over 2, up 1 over 2, up 1 over 2. We could also go down 1, back 2, down 1, back 2. And then we can draw our line. Oh, that's horrible. Let's try that again. We okay with that? Okay, this next one's just a bit of a mess. First of all, is it in general form? Not exactly. First of all, for it to be in general form, A, B, and C have to be integers, or all those values, all those coefficients integers. Yes. However, A has to be greater than 0. Is A greater than 0? No, it's not. -2x plus 3y equals 4. Is A positive? So for it to be in general form, we actually would need to multiply by -1. And now it's in general form. Okay? Just food for thought. Not anything to do with this. Anytime your equation is like this, you have a couple options on how you can go about getting your line, your ability to graph the line. I usually immediately see if I can get intercepts, the x-intercept and the y-intercept. So for example, the x-intercept, isn't that where y equals 0? Yes. So that means I'm going to plug in a 0 for y. What happens when I plug in 0 for y? It does. It's gone. We call it, in Algebra 1, we call it the hand. We just covered up with our hand. And I'm left with -2x equals 4. So what does x equal? No. -2. So now I have a point at -2. Okay, so what if I went the other way? Now I'm going to plug in 0 for x. What happens when I plug in 0 for x? This disappears. Once again, like covering up with your hand, right? Or if you're on a piece of paper, your finger. But does this y pretty at all? So all I was able to get was one intercept out of it. At this point, I need to go ahead and solve it so I can get the slope to get another point. So what would you recommend me do to solve this to get another point? Nope. I'm going to add 2x. And then I'm going to divide everything by 3. Keep in mind, I could care less. All I care about I don't care what it's going to look like. All I care about is the slope. Is 2/3 my slope? Yes. So then I'm going to go what? Up 2 over 3. I'm going to go down 2 over 3. And it looks like I already have my solution. What is that solution? What? Good. You okay with that? So I get the solution by graphing it. But as we saw in our first situation, we actually couldn't because it wasn't pretty. Okay, but then we're going to confirm it by substituting. So if you look at these two equations, how would you like to go about substituting? One thing you may ask yourself is there a variable isolated? And do you understand when I make that statement? What does isolated mean? So, do we have a variable that is isolated? In the first equation, we have y all by itself, correct? And it says y equals all this stuff. So can we take all that stuff and stick it in for y? So let's see. That would look like 3 times y that's isolated equals, nope, minus 2x equals 4. And then in my parentheses, I could take what y equals and plug it in. And this is where we got to be good at math. So let's think about something. When you take 2 times 3 times 4, do you multiply the 2 times the 3 and the 2 times the 4? No, this isn't distribution, is it? 2 times 3, so it'd be 6 times 4, right? Which then would be 24, correct? Okay, what I want you to notice is this is 3 times a half times x plus 1. This is the same thing. So we're going to multiply 3 times a half first. So we got 3 halves, x plus 1, minus 2x equals 4. Now what will we do? Now you do 3 halves times the x plus 1. So we have 3 halves x plus 3 halves minus 2x equals 4. And now you're sitting there thinking, oh my gosh, there's fractions. And you want to turn them into decimals, which I don't know why. That's even harder. We're just going to make the fraction go away. How about that? What part of this number, this fraction, do you want to go away? Really, the top? I would think the bottom. The bottom's the problem. So if we want it to go away, you know what we're going to do? We're just going to multiply by it. But we got to multiply everything. So when I multiply 2 times 3 halves, what happens to the 2's? They just cancel out, right? Does everybody understand what I mean when I say that? Okay, let me write it down. I got 2 over 1 times 3 halves. This is the same thing as reducing. I can say everything on top can be divided by what's on bottom. So 2 divided by 2 is 1. 2 divided by 2 is 1. Do you see how the 2's just canceled out? And I'm left with just the 3. So I got 3x plus, same thing here. My 2's are going to cancel out, and I'm just left with the 3. Now I do 2 times negative 2. And then 2 times 4. We just have to remember to multiply everything to keep it an equality. Okay? Now what will we do? Now we got rid of our ugliness. Now it's just simple stuff. So what do you want to do now? Notice these two. Those are on the same side of the equal sign, aren't they? That means you are combining like terms. So what do we get? So I got 3 minus x equals 8. So now what? So I got negative x equals 5. And then x equals, does that match the x value of our point? Yay. Now we can take this x value and plug it into either of the equations from earlier. Would you like to do the top one or the bottom one? Top one. So we got y equals 1/2 negative 5 plus 1. What was it? Plus 1. What's negative 5 plus 1? What's 1/2 of negative 4? So we have an answer at negative 5, negative 2. Is that match? So we could solve it and get the answer, or we can graph it and get the answer. Solving it algebraically, you'll always get the answer. Sometimes graphing it, you can just estimate because it might be an ugly one. We okay with that? Let's try another. Let's go with graphing it first. Looking at the one on top, what form is it in? Slope intercept, HK, or general? Okay, so if it's an HK, that means you have a point. Write down the point. Don't say it out loud. Check with your peeps, see if they got the same point. I got negative 1, 2. Everybody agree? So negative 1, 2, because insiders lie. Now that we have a point, we can use the slope to get more points, right? So what would I do? I could do down 3 over 4. I could also do up 3, back 4. Just one of them has to be negative. It can be negative 3 over 4, or it can be 3 over negative 4. We okay with that? Our line should be going down because our slope is negative. What about that next one? Once again, we aren't anywhere close to any type of form, correct? So my question is, what if I plugged in a 0 for y? Could I get an x-intercept? What happens if you plug in 0 for y? Huh? It goes away, and what am I left with? X equals negative 5. That's beautiful. So I got a negative 5. 1, 2, 3, 4, 5. What if I plug in 0 for x? Does that do anything for me? Nope, not really. So now I need to get y by itself so I can get the slope. So what would I do first? Add the 5. So I got x plus 5 equals 2y. Now what? When I do this, I really don't care about anything other than the slope. So what is my slope? So I'm going to go up. No, x is not part of the slope. I'm going to go up 1 over 2, up 1 over 2, and there's my answer. So our answer ended up being what? Negative 1, 2. Okay, so now we're going to try to do it the other way. So thoughts? Do we have an isolated variable? We actually got 2 of them, right? We got the y by itself. We also have the x by itself. So which one do you think would be easiest to plug in? So we're going to take this right here and put it right there. So that means I have y equals negative 3/4 something plus 1 plus 2. Notice I wrote out the whole thing, but I put parentheses where x was. If you do this, then it's rare that you'll forget stuff. If you try to do it all in one step, then quite often you'll forget part of the equation. Now I'm going to take what x equals and plug it in. So I'm going to take this right here and I'm going to stick it right there. So I got negative 5 plus 2y. We need to simplify this inside first. So I got a negative 3/4 and I got a plus 2. But what's going to be on the inside of my parentheses when I simplify it? I got negative 5 plus 2y plus 1. I got 2y. I got a negative 5 plus a 1. Negative 4. All we did was what was in parentheses, we combined like terms. We had a negative 5 and a 1. Those are like terms. They're constants. We okay with that? Okay, now I'm ready to distribute. When you multiply negative 3/4 times 2, do you have anything you can reduce? The 2 and the 4 have something in common. They both have a 2 in them. 2 goes into 2 once. 2 goes into 4 twice. everybody okay with that? So now I have negative 3/2 y. Now I'm going to multiply negative 3/4 times 4. Is there anything we can reduce? 4 goes into 4 once. 4 goes into 4 once, leaving me with, and then I have, it's a negative times a negative, sorry, so that's positive. And then we add the 2. So now we have y equals negative 3/2 y plus 5. Now what do you want to do? Is that what you want to do? I would think you'd want to get rid of the fraction. Yes? So what are we going to multiply by to get rid of the fraction? So we're going to multiply everything by 2. So I got 2y. When I multiply 2 times negative 3/2, my 2's will cancel, leaving me with just negative 3. And then I got 2 times 5. Now what? So I add 3y and I get 5y equals 10. And then I get, does that match our solution? Do we have a 2 in the y value? Okay, now we need to go back to either one of our beginnings and plug in 2 for the y. Which one do you want to do, the top or the bottom? So I got x equals negative 5 plus 2 times 2. X equals negative 1. So we got that right there. Correct? We okay with that? So no matter what way we do it, we should get to the same answer, whether we do it graphically or by hand. Questions about any of that? Okay, so things you want to notice. Do you see how this one right here is in general form? Okay, so I'm going to show you the hand. When I put down the hand, that means I'm plugging in 0 for that one. So I'm going to plug in a 0 for y. I have 4x equals, so x equals, and I can go plot x equals 2, boom. Now check it out. I plug in 0 for x, and I got what? Boom. There's my y-intercept. I'm done with that problem. I don't actually have to go get the slope. So if it's in general form, sometimes you can get both the intercepts and you don't have to change the order. Are we okay with that idea? And once again, wherever I place my hand is just where I plugged in 0. But you'll still end up with the 1 left. 4x equals 8, so x equals 2. That means the x-intercept is 2. Okay? Questions? Okay, so y'all got this page. Work with your peeps. And then afterwards, you got a delta math.